Alright everybody, what is up? It's the art programmer here and welcome back to my channel. From the past few years, applying an architectural pattern while developing Android applications has become a norm. Google also released their Android Jetpacks components to support it. But what about legacy systems like content providers? So in this video, we will look into how to implement live data with content providers. So let's jump right into it. In this tutorial, we will make a contacts application which will fetch the list of contacts stored on the phone and then display them in a list via Recycler view. All this will be done via using architectural components like live data and view model. So first of all, clone the master branch of this repository to set up the project. The link will be given in the description. After importing the project, head over to the layout resource folder. And as you can see, I have already set up the layouts for our activity and recycler view item. Further here, the main activity and the adapter for the recycler view is already set up. As you can see, here is the query for fetching contacts list. You can go ahead and compile and run the application. It will run just fine and show the list of contacts. But right now it is implemented without the use of live data or view model. So let's edit the files and try to achieve the same thing via live data and view model. So how do we achieve this? We will make our own implementation of mutable live data class and create a content observer inside, which will notify the live data class whenever there is any change in the URI and post the new values. Further, this live data will post the new values to the UI controller. So, first of all, head over to the data directory and create a new abstract class, content provider live data, as I already have here. This file will act as base class for our implementation of mutable live data class. As you can see here, it takes two parameters. First is context, which will be used to make content resolver query. Second is a URI, which the content observer will observe. Plus, we have this generic parameter type defined here, which will be used to pass the type of objects we want the live data to wrap upon. In our case, it will be contact class or type. So, first of all, as you can see, we have declared a private variable for the content observer that we are about to use. Content observer is a class which receives callback for changes to content. Next, we have these override functions on active and on inactive. On active is called when an observer is attached with the live data, and on inactive is called when it is removed or destroyed. At last, we have this abstract function get content provider value, which we will implement to get the latest values from the content provider. So first of all, as you can see here in onActive function, we are posting the initial value of the content provider to the observer of our live data. This post value function takes in a value as parameter and passes its value to the main thread to set the value. If some consecutive calls are made to the post value function with different values, then the value passed in the last call will be set. Anyway, after setting the initial value, we are creating the content observer object. As you can see here, we have to override this onChange function. This function is called whenever there is any change in the value of the content provider it is observing. In our case, it will be the contacts. Inside the onChange override function, we are again calling this post value function to set the latest value on the UI controller. At last, we register our content observer object with the URI of the content provider we want to observe. As you can see, here are three parameters. First is URI and last is the observer object. Both of these cannot be null. Second parameter is notify for descendants, which takes in a boolean value. If it is false, then the observer will only receive callbacks for changes in the specified URI and its ancestors. If it is true, then the observer will also receive callbacks for the child URIs too. Anyway, that's it for this onActive function. And as you can see in onInactive function, we are simply just unregistering our content observer. As I mentioned earlier, we will implement this getContentProviderValue abstract function to query the latest data from our content provider. So that's all for this abstract class. Next thing we will do is to create a concrete class and implement this content provider live data class. So go ahead and create this file called contact live data. As you can see here, we are taking context as a parameter to which we will pass our application context. Further, we are extending the content provider live data we just created and pass in a list of contacts in the place of generic type. Also, if you remember, this class takes two parameters. First one is context and second one is URI. As you can see, we are passing this contact URI. You can Google this to learn more about it. Next, we have this private function getContacts, inside which we are using the content resolver to query the list of contacts from the contacts provider. You may be familiar with this if you have previously worked with content provider system. Otherwise, just Google about it to learn more. It is really simple. At last, as you can see here, we are overriding the getContentProviderValue function to make it return the list of contacts via getContacts function, which further queries the data from the contacts provider. So every time if there is any change in the data, this function will query and get new data. So that's all for this class. We have successfully implemented live data with a content provider. That was a lot of work. Next, we will look into how to use this class. Meanwhile, if you find this video useful, then make sure you like this video and subscribe to my channel. And if you have friends who could also learn from this video, then make sure to share this video to them. Now back into the tutorial. Next thing we want to do is to use this contact live data class to show the list of contacts in our main activity via recycler view. So first, let's create a view model class to manage the live data according to the life cycle of this UI controller. In our case, it will be main activity. So first, right click under data and create a file, contact view model. As you can see here, we are taking an application object in constructor and extending the Android view model class. Further, we have a contacts variable which is holding a contact live data object to which we pass the application context. So that's all for this class. Next, we modify our main activity class. So in your version of main activity, you already have this private function here which queries for contacts list, but we no longer need it. So just remove this part and modify this setContacts private function to actually use the view model. So now, as you can see here, we are initializing our view model class and then attaching an observer to our live data. So that's all. We have successfully implemented live data with content provider. You can go ahead and run the application and try to rotate the device so you can actually see the view model in work. Now if you get stuck anywhere, you can always check out the GitHub repository of this project. The branch will be Jetpack, link will be given in the description. Thanks for watching the video. I'll see you guys on the next one. Stay safe and keep learning.